IMAUG. If you want to connect with us, here's our email addresses, and all of our meetings we try our best to schedule on Meetup at least a month out, at least the date and time, so you guys are in the know there. We have Twitter. Everything that we present will be on the YouTube channel after a few days. So if you missed this or want to go look at something else that we've had historically, feel free to go do that. So today will be a talk on Bicep by me. The 27th will be Machine Learning Part 2 by Simon, and then August 10th will be Kubernetes by Jeremiah. And if you want to learn more about anything Azure, there's free resources out there for you. And always feel free to join our Slack, drop any questions, concerns, things you guys might be fighting or running into. We'd be more than happy to help where we can. If not, hopefully we can find somebody that can help you. And then today's sponsor will be Source Allies. I'm going to pull up the info I have. So Source Allies is a local technical consultancy who values collaboration, craftsmanship, and an ownership mentality. We provide a home to our teammates, and we encourage each other to grow not only technically, but as peers and consultants. This is evidenced with the quality of software we deliver to clients. I may be biased. It's a pretty good place to work. If anybody wants to learn more about them, feel free to reach out to me directly, or I can get you hooked up with one of our recruiters too. Or in the future, I'm sure this user group will probably at some point be at Source Allies, and there will probably be recruiters there or just people. And there's other people on this call from Source Allies. So if you have any questions about them, want to learn more, feel free to reach out to us. I think we're always looking for full stack developers, automation QA, I think delivery leads. So if any of those interest you, feel free to reach out, and I'd be happy to answer any questions or pass it along to somebody else if the recruitment path is where you want to go. And with that, I'm going to pull up today's presentation. Maybe. And I'm going to be bouncing around between some things here, so let's see how this works. So today's presentation will be over IMAUG, or will be over ARM versus Bicep and deploying it via GitHub Actions. So who am I? As I said before, I'm a Source Allies employee, Azure nerd, newish Waukee resident, dog dad, Azure barista, and then here's my email if you have any questions. As you can probably tell, my mental bicep and physical bicep, both use a little bit of work here. So if I say anything not quite correct, feel free to correct me or hop in with any questions. I'll do the best I can to answer during the meeting. And if not, I'll hopefully get back to you after this. So feel free to interrupt or ask questions as you have them. So the reason why we should be looking towards Bicep, the future of Microsoft is kind of an unknown. Nobody really has a crystal ball to say this is the for sure and forever future, but the direction that development seems to be going at Microsoft is Bicep, full ship and sail, and you can do some sort of ARM stuff underneath. But the future that it seems like they're presenting right now is code repos and pipelines are going to be in GitHub, and Azure DevOps is also going to be in parity with that for a little while. And then infrastructure as code is one of their primary development practices, and then just cloud as a whole. So when you start talking about GitHub Actions, first thing you have to talk about is how you're going to connect to Azure. And there's kind of two different methodologies here. You can use what's called a managed identity, which doesn't have a username or password. It'll log in basically on your behalf, and you can abstract some of that stuff out. And then you can assign different access based on that. Or you can use what's called a publish profile. So this is a profile that has basically a username and password in it, and then basic auth to just publish to the resource group that you create it for. The nice thing about managed identities is you can have one and give it permission to everything. The nice thing with published profiles is they're kind of a little bit simpler. So if you're just doing like a one thing kind of approach or just one app, you can, spin one out real quick, have it very secluded to just the one thing. And you can do this with managed identities too. It's just a little easier to spread them around and give them access to things they shouldn't potentially. So for this talk, I kind of went the managed identity path. And I can kind of show, I believe, yeah. So this scenario that we're working right now is, I believe I just have a web service or an app service and a function app, and just deploying it to Azure in two different resource groups to show both how you would do it in ARM and how you would do it in Bicep. So we'll go first to the GitHub actions, because I think that's where the workflow is going to start. So in this repo, this is kind of the templated out part of GitHub actions. Basically what this says is that any pushes to master are main, and any pull requests against main will run this. Probably don't want that since this is actually deploying code. But for right now, because I only push straight to master for this demo, it works for any concerns we'd have, but I'd probably remove this if it was going to be anything semi-production-y. As far as running the code, it's just running on GitHub's Ubuntu latest. The first thing we will do is check out the code. Then we'll use Azure login. So you'll run, what I did behind the scenes is do a CLI command to create a service principal that can push to both of my resource groups. And I should pull that up. So this is my personal Azure account. And for this one, the only one you really need to worry about is the ARM group and the Bicep group. So these are just two resource groups I created prior to pushing any code automatically. And that's what the service principal, the single service principal is going to have access to both of these two. So then we're going to use the credentials that the CLI pops out for environment variable, and we'll save it into Azure credentials. That's a JSON that it'll use to basically get it access to go to the cloud. Then the first step we're going to do is use that credential file and the ARM template to deploy the resources. The next thing we're going to do is deploy the Bicep resources, run the name of the container, and then we're going to log out with AZ logout. I don't think the logout is required, but it's just kind of a nice full, we logged in, let's log out at the end to make sure we don't have any open connections that we shouldn't. And let's put this over here. So kind of the pros for the ARM example today. It's basic, it's written in JSON, and it's kind of computer language. So you don't really need a smart editor for this. You could get away with Notepad++. Like, you don't need anything with any bells and whistles to write JSON. It can be pretty much any text editor. I'll show you kind of what that looks like. So in this particular example, we're looking at about 162 lines of code. We have our parameters file here that will, and a lot of these are by default brought in one of the templates. So we have our parameter, which is a parameter in ARM is basically something that's overwritable. But if you're not planning on overwriting it, you could do something like this where you have a default value. This could also honestly be a variable. I was just more using parameters and variables to kind of show the differences between ARM and Bicep. So all you really need to know is these are kind of variables that are passed in typically via an external file. And then these are variables that are declared in this file particularly. And then you can use any sort of built-in functions like concat. This is reading the parameters file. They have to lower, to upper, all those kind of like string altering functions. There's a lot of those pre-built, so you don't need to do anything too crazy to align with some of Azure's requirements of like, this resource can only have lowercase names. This resource can have whatever. This resource can't have non-text characters. You should be able to hopefully manipulate your strings however you need to here. And then for our resources, we have our storage account. This is where the Azure function is going to store its files. So any files that are not going to be, running at all times, or any logs, those are all going to be dumped into here. Then we have our server farm. This is where I believe the app service plan is here. So this is what the actual server that the app service runs on. And we just specified it as Linux and reserved it. So it shouldn't go down or not be there. As far as sites goes, here's the actual app service. So this is the provisioning of the server that your app itself will be running on. So there's a lot of stuff here specifying where it's going to run on, the name, the location, some conditions on it. And then here's our Azure function. So Azure functions are basically AWS Lambdas. They run on a cron. They can be HTTP triggered. It's Azure's serverless offering. And same sort of thing. You got your name, location, kind. For an Azure function, there is a lot more configs that they want. We'll come back to this a little bit on the Bicep. But again, you need to tell it what server farm to run on. And then Azure functions do require app insights. So that is Azure's built-in logging service, metric service. There's a lot of things you can do with app insights. So here's just a basic app insight instance. Kind of downfalls for ARM. Because it's JSON, there's a lot of long lines. It wasn't really intended to be human readable. The idea with JSON was supposed to be computer-to-computer communication, and then humans we inserted ourselves into there. So it's not super clean, and that's okay. It gets the job done. It's super basic, super bare bones, and with that comes not a lot of issues as far as like overcomplicating what you need to do. So we'll go to the Bicep example and kind of the pros for that. And we'll do a side-by-side here so you can see the difference. So the difference between Bicep and ARM is Bicep is kind of I believe they call it a transpiler. So it's like a level above ARM that your code will eventually be broken down into ARM. But because it's a proprietary language kind of on top of that, it's a lot more human readable. There's a lot more bells and whistles you can do with it. And there's a lot more snippet action that can kind of help you, be more productive and make things more readable for you. So one of the pros, the other thing I forgot is there is also linters in Bicep. So you can also then hold your team accountable if they're, having unused variables, unused parameters. That will actually fail your deployment, which is cool because then you don't have like a 300-line ARM template file where you have variables of who knows what's being used where, and you have to control F and try to figure out if it's being used before you just remove it. Or your Bicep instead will say like, it'll give you this linter warning. And then if I went to deploy this, it would actually fail my deployment because the linter will say, oh, hey, you have an unused variable. Like, we're not going to let you do that unless you specifically go into here and tell it to ignore that line, which is pretty sweet. And then right off the bat, so parameters are a little cleaner, I think. You specify the type of the parameter, and then the value. So if you look at something like location, it's using this. If you're familiar with ARM, it's a familiar bracket notation. It's kind of like what a $ and squiggly braces are in other languages. It tells it to evaluate or run this function and then grab that location. I think this is more, I would say, like method-based or JavaScript-y, where you can just call a function to grab your thing, and then you can see that object, what it returns, and then you can read it. So you can do a few different things on your resource group. I don't know if it's going to let me do that from here. So you can grab your ID, location, managed by name, properties, tags, a bunch of different information on this that normally you would have to access by calling a bunch of helper functions here, and it just ends up making a long string. So if we go to, I think I'm doing that here. So something like this, if I wanted the ID of the app service, I can just call, and we'll get to this a little further down. I can call my resource or whatever I'm looking at .id instead of having to do resource ID, this type of object, here's the name of it. Okay, now I have it. We'll do that a little bit over here. Variables are declared similarly. You do not have to define a type for a variable. It is inferred on, I believe, deployment time, so you shouldn't have to do anything crazy with that. And then your resources. So these are one-to-one matches for the resources that we have in ARM. The nice thing about writing resources in Bicep versus ARM is, again, the auto-completion. So if we just blow this one away, call this storage account. So then we'll say the type. It does have autocomplete, so I can storage accounts. And then I can pick which version I want. So the reasoning for the versioning here is it's supposed to be easier to upgrade this way versus in ARM, you're kind of locked into this API version. And if that API version goes away, you're kind of in trouble. Your app will stop working.
Well, the other fun thing that I've run into with that recently is the ARM TTK, the test kit, actually gets really mad about any templates over or using an old API version. And the 2019 version is 2 years old at this point. So it started failing a bunch of the tests.
Oh.
So then you have to do an explicit, hey, skip and ignore the API version, because if you pull it forward, there's no guarantee it's going to work completely. You have to do some extra hands-on testing to make sure that nothing changed that you're depending on.
Right. That, fields that aren't required are required now, or vice versa. I think that's one perk of Bicep too. If you start deploying something or using something that's required, it does, I believe. Let me make sure I got the right. So if you hover over here, it says a specified resource declaration is missing required parameter name. So there is some helpful text like that too as you're writing your Bicep, which ARM doesn't really have. Because in the past, in my experience, you're writing your ARM, you then have to commit it or get it up to a server somehow, then deploy it, then you realize you missed something, then you're back in here doing it again, and you're just slowly getting your template file to be exactly what Azure is expecting. And that can be a lot of guess and check work, and it takes some time. Whereas I liked in Bicep, there was a lot of stuff that was like, hey, don't you need this. I'm not going to even let you save, or I'm going to throw red squiggles everywhere. I'm going to freak out if you don't have this, instead of like, oh, duh, of course I need a name parameter. But in JSON, it just kind of fell into the fold here of the resource. The other thing that's cool in Bicep that I wanted to point out, or I guess there's a couple other things, is commenting is supported a lot better. You can do single line or multi-line, whereas JSON doesn't really like comments, other than there's like a comment tag you can throw on stuff. But if you want to do really lengthy comments, then you end up multi-lined, and it's just very long. Versus here, you can comment wherever and explicitly you want. So you could say, you know, like, I don't know, depending on the server farm, because can't deploy if it's not there. Or, you know, whatever you need to do to make your code as explicit as possible, depending on, you know, who might be maintaining this or whatnot. You can do all that. So versus a really long file like this, where you hope the person who did the ARM template before you added comments, but they're not required. And it's sometimes hard to follow, you know, when you're getting in resources nested in resources, where everything goes. So you can throw some comments wherever you feel like it. The other thing that's kind of cool is I showed you over here to be dependent on our server farm resource. We had to first call the Microsoft resource ID, feed it the resource type we were looking for, then the name of it, and then, you know, we would get it and be dependent on that ID. In Bicep, you don't have to do that. You can just say, hey, we declared this server farm variable up here. Let's just be dependent on that. So don't deploy this until this resource up here is done. And if you do the .id, it'll actually even show you, because unintuitively, I would think, you know, to make it one-in-one feature parity, I should be dependent on the ID like I am in ARM. But no, it's a little smarter than that. So it's like, you know, hey, you can just specify the module. You don't need to give us the ID, which is cool. And then behind the scenes, it'll grab the ID of that item. The other thing with Bicep that they are starting to do, which I really like, is they're starting to get rid of some of the things you don't really need to worry about. And I'm sure this is a work in progress as they're getting better, and, you know, building out that abstraction layer above ARM. For example, just in Azure Function alone, there's these two site configurations that you used to have to do. Over here, you'll see it in the ARM. Here, and I don't know where the other one went. But they're just not required anymore. Our Bicep is extracting those out because the content share settings and file connect, not that one, right here. The content share settings is just going to be auto-generated for you. You don't need to know about that. So they're just not going to give it to you or make you require it. The other thing that's kind of slick, again, with the whole dot notation, is app insights. So we probably, I didn't do it in here. We probably should be dependent in this particular example on app insights because you need it to do an Azure function. But to reference the implementation or instrumentation key in Azure is usually this. So you reference your ID, your resource, then you need to grab it by ID, which is the name. And then in order to reference it properly, you also have to tell it what API it's using, so it knows that it's grabbing something that exists. And then the dot notation. This is a really long line when I can just say, hey, grab me your app insights, the properties on that, and I need the key. And you can do that with, I believe, any resource. So I can see, you know, all of the properties that are configured on my app insights. So it should help cut down on a lot of those long lines, or, you having to go and really look at something and say, all right, what is this exactly doing? What does reference mean? What does resource ID mean? If you're just given an ARM template out of the box, this is more human readable of, okay, this is the name, the value is app insights. We're grabbing some sort of instrumentation key. Cool. There is some drawbacks with Bicep though. I think I've been pretty pro it up until this point. So I just linked Microsoft's docs known limitations for right now. The single line arrays are not supported. So if you look back here, for example, like server farm, if I wanted to add another resource here in Bicep, it's a new line. If you don't like that, you don't really get a choice. That's just how it chooses new items or different entries into the array. It's just new line. No support for breaking long lines into multiple lines. So if you look at this, the resource line, this does all have to be done in a single line, which, just declaring variables isn't bad, or declaring resources isn't bad. But when you start getting into, conditional variables, it starts to get really lengthy, kind of like ARM, and you can't write it like this.
Is there an escape character or anything like PowerShell has, like a backtick that you can do?
Not that I'm aware of. I don't think so, but I also haven't tried it. I kind of just took this as face value of you can't do it.
Okay.
That'd be something good to look into, though. I can. Let's try. I mean, this is a real functioning pipeline, so. You said it was backtick?
Yeah, I mean, that's just one of them for PowerShell. Or you could pipe, I guess, too, but that's different. I doubt that would work here.
Just a single backtick?
Yeah. Yeah, it looks like that doesn't work.
Yeah, it wants a brace, bracket, or if. So I don't think that works. Other known issues are no support for the concept of an API profile, which is used to map single API profile to a set of API versions for each resource type, and then no support for user-defined functions. So you do have to kind of use Microsoft's built-in functions. There's no real way to roll your own at this point. And this is all just general Microsoft documentation. So we kind of been looking at this side by side up until this point. So this is a real pipeline that we can use. One thing we could do, let's go back to here. And you'll see in my GitHub actions, this was some trial and errors. So for the Bicep implementation, we can run the deploy. And if you're missing, or if you have an unused variable, this is kind of what it looks like in your pipeline. So for example, I had a variable that used to be called hosting plan and was never used, and actually broke my deployment because of it. And then there was also, where to go? I also created my two resource groups too similar. So a storage account name is something that needs to be globally unique, and because I had it in my ARM project, it couldn't be the exact same name as the Bicep. So if we look at the ARM group, we can kind of go over to here. You can see that all of the resources are created, nothing too crazy. We have our deployments. And then Bicep, just identical. And that's what you would hope for, is that you can't really tell at the end of the day if somebody is using Bicep or somebody's using ARM. They can use whatever language or format is more familiar to them or one that they would like to use. Let's go back. Let's see what this one was. I think this one was missing a field that was required. Yeah. If we go to the Bicep group, looks like it didn't keep it. That one was just, there was a field that required something to be assigned that wasn't there.
Where are you specifying if it's complete or incremental? Or is that a thing with Bicep?
With GitHub Actions, I don't think I'm specifying it in either. So I believe by default it's incremental.
Okay.
I probably need to throw Azure in there somewhere. These are long. Empty. Here we go. So by default, if you don't specify one, it's incremental, but you can also change it to complete or validate only if you want.
Okay.
So earlier how I said, it's kind of running this on all pull requests. I could instead on pull request do my branch and run validate only or incremental or validate only.
Okay.
That way we can, have validation on PRs and not have to worry about that once we go to.
I didn't realize that's using the same step template as the ARM deploy itself. It's the same thing.
Yep.
Okay.
Yeah. So that's one thing that I thought was weird too. They're both actually using the Azure ARM deploy. It's smart enough to behind the scenes see if you're giving it JSON or Bicep, and then it turns your Bicep into actual ARM code behind the scenes, and then we'll deploy that up through the ARM deployment.
Okay.
But yeah, I did the same thing because I was like, okay, what do I use to deploy Bicep? And then all the help docs are use Azure ARM deploy. Okay, that seems a little weird, but it kind of makes sense because what's actually going to Azure is ARM at the end of the day. I don't think it's Bicep. And then some extra links I had at the end here. There is a cool Bicep playground that Derek shared with me when writing this. I think it's this one. So if you want to put your code in here, I believe it will help you turn your ARM template into Bicep code. And then it kind of shows you apples to apples comparison. I don't know how well it works just by pasting templates in here, but it's a place to mess with and have some fun with that. And then there's some just other help docs I've grabbed resources from throughout this. And then all this code is on my repo for IMAUG.
So if you were to use like different parameters in different environments, would you use a parameters file as well, or would you try to do an individual file for each environment?
So in the way we've done it in the past is we've had a singular parameter file that is JSON substituted by environment variables in the pipeline. So you could go that approach here where you have a single parameter file and then it's the resource. I believe something I didn't show here. I believe there's a way to do that built into ARM that I saw. And this wasn't the exact link I was at, but see if I can find what I was looking at again. I believe there's a way in Bicep to say, here is, because you can throw in different parameters files, but I think there's, no, it's not in here. I thought there was a way to say like which environment pick which variable. But maybe I'm misremembering. I can add that to this. So you can kind of do it however you want. You could do the multiple variable or the multiple file approach. The only downside with that is you would need to still obscure your variables somehow. And in my past experiences, since you're obscuring them anyway, putting them somewhere else, I've just used a single file. But I have also seen where you just do multiple files, because then you can have a little more flexibility with configuration, and anything that doesn't need to be obscured is then hard-coded, checked in, not something you can change on the pipeline. So It's just kind of a team definition at that point of, if I need to, for example, change the, where'd it go? If I want to change the SKU of, my app service from B1 to B2 or to a P1, which is just giving you more resources, should that be a code check-in or should that be just a configuration change? And I've heard both sides of the argument. I'm not. If you have a more, or go ahead.
I think for some of those, the big thing would be understanding, is this a destructive change that is going to, delete disks if you were deploying a VM? Did you change the storage type, which might just make it faster and it'll migrate the data for you? Or did you actually change the VM type and that's going to delete and recreate the VM? So can you make the change non-destructively? Because yeah, sometimes it's like, well, we need more resources. Okay, well, is everything we're doing config as code? Or is it a simple app function where we can replace the whole thing? Or do we need to have something that if we change it, it needs to be a code check-in because it will blow stuff away?
And don't only think about blowing stuff away, think about a traceability factor. So you're checking stuff in, you have a log of who and what changed. So from an organizational standpoint, you may think, hey, I'm only upgrading this to get some faster response time for my storage. But in reality, you're also costing the organization more money. They want to know who did that and why. Yeah, so it's always good to check that in and have that traceability factor.
Yeah, that makes sense.
That's a good point. I know in Azure DevOps, there is traceability there of who changed the pipeline, but it's not as clear as like a code commit either, where it's like, hey, I'm upgrading this because reasons, and you can put whatever reasons you have versus just like the pipeline changed.
You can put comments in. It's not like a required thing, but you could.
Yeah, but it's hard to, if you try to spot the difference too. I mean, have you looked at like the comparison of like a git commit compare will take you to like just this line?
Yeah.
Whereas if you did that in a pipeline, you get the whole pipeline and it there's like versions of things alternating that you maybe didn't touch.
Yep. Yeah, it might take a while for you to find in the history when something changed in the Azure DevOps side.
Yeah.
Yep. That makes sense. So in this case, did you have a parameters file you were using, or were you just doing default values for everything?
So I did default values, and then I believe there was a parameter. I thought I was passing one in. I might not have been. I wasn't using parameters. If I did, I thought I was passing one in from here via the CLI, but I don't. I must have dropped that. So there isn't any parameters file. They're just default values to show like this is how you do a parameter.
Sure.
So these all are essentially just variables hard coded. Cool. Is there any other questions?
So one thing I threw in the chat was if you look at your side-by-side or in the Bicep playground, there is actually metadata generated there on the right side at the top. And so the ARM TTK will actually use that to figure out if there are certain rules that it should apply or skip, because Bicep does some not best practices, but only because it controls the inputs and outputs. And so it's not as error prone as if a user was editing a template and putting in a certain type of reference. But that's kind of an easy way to figure out, was this just a straight ARM template? Or if somebody told Bicep to output the template, was it Bicep generated?
You're talking about like the schema and the content version stuff?
The next one down, the metadata. Yep.
Gotcha.
Because yeah, I pasted in the chat, the ARM TTK, they actually have one of their tests checks to see if it was generated by Bicep, and then it skips the test because Bicep doesn't adhere to the best practice because it needs to deal with the resource a slightly different way.
Gotcha. Hopefully they're in the process of fixing that. I think they just announced Bicep is, I don't think it's in the 1.0 release, but it's good enough to be used in production at this point. There shouldn't be as many breaking changes coming out, is what I think I heard recently. So it'd be good to have the testing kit that you could do that and test it.
And I think it does actually support the Bicep files. Like you can run the TTK and it can detect, if you give it the file name, it can detect that it's a Bicep one, and it runs Bicep under the hood as long as you have Bicep installed.
Cool. And it probably checks it at like this level before it gets to the actual ARM template level, I would assume, maybe.
Yeah, I am not sure what level it checks it. One thing that was interesting is the client that we're currently at has some older ARM templates, and one of the things that they had done was make the API version a variable, and the TTK really does not like that because it does not resolve the variable and then replace it in the resource. It says, hey, you don't have an API version defined because you're trying to specify it from a parameter, and it doesn't actually resolve the parameters. It just says, hey, is everything valid minus the data? And the data shows up as empty because it ignores the parameters.
Would you recommend having these as parameters then, or would you recommend hard coding them and then if you need to change them, doing a code check-in at that point, because then you can make sure that everything is working as expected.
I definitely like the full version specification. The one thing that is kind of challenging with the TTK is because they care about the API versions, you may have to run like an additional lint check if you're ignoring that. If you have a big mix of like top level schema 2019, now there's 2020, but like over on your virtual machine in Bicep, well, that's the 2020-06 one. Well, do you want to keep that at the bleeding edge or do you want to pin that? Well, if you pin it to what you started with, you'll start getting some warnings about old APIs. So you have to kind of balance that. How much code do you want to maintain? I would say it's better to be explicit and not try to be clever. And, oh, well, we're going to make this API a variable. The thing is, depending on where you're using it, if it's a compute virtual machine resource, it might be 200601. But if it's the virtual network resource, it might be 200713. So you're not guaranteed that all of your versions are going to be the same. So it's better to just keep them as their own separate thing. And then if you're searching for it, try to do a find and replace and actually test your template.
Mm-hmm. And that makes sense. I think I've seen similar things with even the like app services. Not everything is on the same version or the same naming. So you can't make a global change and say like, oh, we're going to move this entire template to 2021. I don't know if there is a 2021 version out yet, but just say there was. I don't know if you can do that. So I think that makes sense that you would be overly explicit, because when you want to change something, you want to verify that, like you said, you didn't just hose your VM by just making a huge breath-changing change without understanding all the depth behind it.
Yeah, and that's where really the autocomplete with Bicep is pretty beautiful because it gives you the valid versions. You're not just kind of, well, let me change this number and see if there's one available. It knows, hey, this is the valid list. I'm pulling it from an API somewhere. These are exactly the ones that we can use.
I don't think I'm going to get that rule over here, but yeah, you can just maybe. It's not going to do that now that we're talking about it. But yeah, then you don't have to hunt and peck and hope you found the right one. Overall, I think it's really cool. I think my final thoughts on it is just it feels more intuitive to me than ARM. ARM seems like there's a lot of like stuff in there that I don't, as a developer, always necessarily care about. And there's also things that, right or wrong, in the docs that like it says it's not required until you go to deploy, and then it's like, oh hey, you're missing this required thing in properties, or vice versa. Or it's required in a very special edge case, so it's like marked as required. I think this is a good step in the direction of like bringing this up a level so that developers don't necessarily need to know all of the metadata that goes on. And if you do want to, it's cool to still have ARM. But if you don't, and you just like want a VM that runs or a Azure function, it's cool that we're going a step closer to just saying, give me an Azure function, and I can wire up all the resources behind the scenes, or wire up everything kind of variable E.
So one thing I noticed at the top, that @secure annotation, does that just secure the next variable up on line 4?
Yeah, I think it's because it's a secret password. So this, and let's here, make sure it's secure. You can use the get secret function to get a key vault secret and pass it. can only be called on Key Vault and can only be used with a parameter @secureDecorator. So yeah, it looks like that is something that is stored in Key Vault. And then this is a way that, because I believe it does just dump out a lot of your stuff into the log. So that way you don't dump out your admin password when it's just logging what you're doing.
Yep, that makes sense. And that's cool that it can integrate. I'm curious, like, how does it know which key vault to go from? Or do you have to have that as you have to have it in a two-part? You have like your base bicep config, and then you have your like resource specific one.
You have to have the get secret value, right? That there's a function for get secret, at least in that example.
Yeah, I was trying to see. Does it show
What the secure annotation is if you guys are familiar with the secure string type in the JSON templates, it's equivalent to that.
Okay, gotcha.
And in that, they're specifying the key vault in that resource section. Resource KV, that's where the key vault is specified.
Okay, so the @secure annotation just marks the one as secure, but then in the second one, it's actually retrieving one directly from Key Vault.
So I wonder if, where's admin password being used? Is it? Yeah, I think this is marking it as a secure string. Okay, and then this one is the Key Vault. Gotcha.
So are you setting the secret as part of your deployment then, I'm assuming? Somewhere? Or is it just randomly in a string?
This is just a random template.
Okay.
That loads with the Bicep Playground. I'm assuming. I wonder if we go over here.
Well, it's listed parameters, so I'm guessing you'd have to specify it.
Yeah, so it looks like it's passed in as a secure string in this particular example. So you would pass that in your parameters file. Cool. Is there any other questions, comments?
So how does this compare to like Terraform and the others? It just looks like it's kind of built into Azure, so it's easier to use. You don't have to like set up storage accounts and that kind of thing.
I am not super familiar with Terraform personally. I think the big downside to this, if you're looking at something like Terraform, is this is, I believe, an Azure specific language at this point. And I don't know if there's any plans to make it more than that.
The other thing with Terraform is with Terraform it has to store the state somewhere. So tracking those states where this is stateless. So it will create the ARM and compare the ARM against the back end and send those changes across so it's not having to maintain a state file somewhere like Terraform. Plus, like Alex said, it's Azure specific at this point.
That is something I will add to this, because that's something I honestly don't know, and we'll hopefully dig into that a little more.
Yeah, and that's a good point with the Terraform and the state. Part of the reason that it does that is it makes it faster to apply in the future, where the Microsoft mindset is check, see if something exists or not, rather than just trying to create it and handling the error. So like the Python and Terraform way is, hey, we are going to try it, and then if something's already there, we'll handle that. Or with Terraform, they track the state. the Microsoft mindset's more, okay, check where I'm at, and then handle this complex conditional logic. Okay, does the resource group exist? No. Create it? Yes. Delete it and recreate it, or reuse that ID. And so Bicep probably follows that similar mindset of, okay, under the hood, when we're doing an incremental, we're going to check, does this already exist? If so, we're going to update it and roll it out. With Terraform, everything is basically automatically figured out. With Bicep and ARM templates, you kind of decide incremental, just modify things or add things, or complete, tear it down and recreate it from scratch.
Cool. Do you know what does the time difference usually look like for that then? Since Terraform's kind of predetermined, are they typically quicker, or are they typically?
Yeah, Terraform can do it in like 2 seconds if it's already been deployed. But like they said, so it's kind of complex at the Corteva side because you have to have like a separate resource group with blob storage enabled and then store that state file. And that can get really hard to manage since we do resource groups sort of segregate our deployments right now. So.
Yeah, the one thing that I've really liked about Terraform versus ARM templates, or even against like the AWS CloudFormation, is it's really good at change indication. So if you change the name of like an S3 bucket, which is equivalent to a blob storage store, that is actually a destructive operation. It has to delete the old bucket and create a new one. Where if you're just changing the instance size or the storage allocation type, it's a non-destructive change. And so Terraform will print out this many resources added, this many changed, and this many destroyed or will be destroyed. And so you can plan, get a count of what's going to change, and then apply that plan. Where really with ARM templates or Bicep, it's you can validate it, but it's kind of a shallow validation. It doesn't actually tell you what's going to change, and then you apply it. And that's kind of your options. Terraform, you can do a little bit more planning, and you can actually get it deleted.
With Terraform, if you end up making a manual change outside of the Terraform process, it can break some stuff. So like if you rename a storage account and then you rerun Terraform deploy, it'll produce some problems probably for you.
Yep. Yeah, if you're going full config as code, it's a pretty useful tool because yeah, it can track all of those. And the one thing that's kind of nice about it is it does do some of that checksumming for you to make it faster to apply. There are still times, depending on how many resources you put together, that it will take a little while, but they recommend, segregating things down similar to how we do with resource groups and specific environments, and not having, hey, this is our entire company infrastructure in one repo.
Sure. So if you segregate it more, it's quicker because it's doing less. Ultimately, it's less state to keep track of and less things to compare against.
Yeah, if you didn't change the Terraform file at all, it doesn't even check with Azure. It just assumes that everything's deployed and then it moves on. So
cool. With that, it looks like we're right about at a little over, so I will
I'll go ahead and turn off the recording, Alec.
Okay.